Imagine a clear night, the kind that feels quiet even inside your chest, when the stars appear one by one and the air seems to pause with them. You tip your head back and the sky looks like it keeps going, past the rooftops, past the clouds, past even the thought of distance. Welcome to a slow journey, a soft stroll through a very large idea. Tonight, let your breathing settle, let your shoulders drop, and let the day release its grip. We will wander gently through a simple wonder, whether space ends, whether there is a final place where everything stops, or whether the path continues without a wall. What time is it for you at this exact moment? Thank you for sharing a quiet moment here. You can picture this as a cozy story, not a race or a test, just a calm exploration. You are listening, and you are safe. The light of your screen is a small glow in a wider dark, and that wider dark is what we will talk about. When people say space, they often mean the stretch between stars and galaxies, the vast in-between that holds it all. When people say end, they might imagine an edge, like a cliff or a fence, a place you could arrive at and touch. In everyday life, most things do have edges. Your street has an end, your cup has a rim, so it is easy to imagine that the universe should be similar. You travel far enough, and you reach the border. But space is not a street, and the universe is not a cup. The way it behaves is broader and quieter. To explore the idea, we can start with a simpler thing, the part of the universe we can actually see. You can picture it like a big, almost spherical bubble around you. Inside that bubble are all the galaxies whose light has had time to reach us since the beginning of the cosmos as we know it. That beginning is not a point in space, and it is not a fireball in a corner. It is a moment everywhere, a time when the universe was much hotter and denser, a time called the early universe. The light from those early days has been traveling to us for billions of years. As it moves through expanding space, it stretches and cools. What began as a brilliant glow now arrives as a dim, radio-like whisper across the sky, a soft afterglow called the cosmic microwave background. You do not need to remember the term. Just imagine a faded echo of brightness, a warm blanket laid across the universe, arriving from all directions with a steady, even tone. Because light has a finite speed, and because the universe has a finite age, there is a limit to how far we can see. Even if space contains more, our view today is bounded by time. The boundary made by time is called a horizon. It is a little like standing in fog at night with a lantern. The fog is not a wall. There may be more trees and more field beyond it, but your sight fades. The cosmos has a horizon like that, not a hard edge, just a place where the light from beyond has not yet arrived. This is the observable universe, the sphere of what we can see and measure now. If you hold that picture gently, the next idea is easier. The observable universe does not have to be the whole story. There can be more beyond the horizon, much more. It is very natural to ask whether the total stretch of space ends somewhere just out of reach, or whether it continues indefinitely. To approach that question, astronomers and physicists look for clues in the light that does reach us. They measure the way distant galaxies recede, the way space itself grows, and the subtle patterns in that old afterglow. The patterns tell us about the shape of space on large scales. Not the shape of a single mountain or a single star, but the gentle shape of the entire fabric of distances. Try a simple picture. Imagine drawing a big triangle on a flat floor. The angles add up to a neat total, always the same. Now imagine drawing the same triangle on a balloon. The angles can add up to a little more. On a saddle-shaped surface, they can add up to a little less. You do not need formulas to sense the idea. The background can bend in different ways, and that bending changes the results of simple measurements. Space can be like that too, across enormous spans. It can be very flat, or slightly curved inward like a sphere, or slightly curved outward like a saddle. The way distant light moves and the way sound waves left imprints in the early universe help us tell which of these broad shapes matches reality. Observations today suggest that on scales we can probe, space is remarkably close to flat. Not perfectly proven down to infinity, but so flat that the difference, if any, is smaller than we can detect with current instruments. Flat space, stretched across a vast universe, has a quiet implication. If the bending is essentially zero, then the simplest continuation of that geometry is that space either goes on indefinitely, or it is so large and gently curved that any loop back on itself would be too big to find so far. In practical terms, no wall appears. No rim announces itself. Even if space is not strictly infinite, it can still be without edges. This is one of the softer, counterintuitive points. People often picture finiteness as something that must have a boundary, like the shoreline of an island. But mathematics gives us examples of shapes that are finite in extent, yet have no edge. The surface of a sphere is the most familiar example. If tiny people lived only on the surface of a perfect globe, they could travel in any direction and never find a cliff. They would visit their own starting point after a long journey, and still, at no moment, would they see a line that says stop. The surface would be finite in area, yet unbounded. In 3 dimensions, there are shapes like that too. Space could be finite without an edge, curving back on itself in a way that is hard to visualize, but easy to accept in a gentle way. Travel long enough, and you might loop. You would not drop into nothing. There would be no outer gap to fall into, because the concept of outside would not apply to the whole. There is another way the universe can be finite without edges. One that feels like a puzzle, but again stays friendly once you settle into it. Consider a video game where moving off the right side of the screen brings you back on the left. The playfield is finite, and the rules loop the positions, so there is no border inside the game world. Mathematicians call that kind of global arrangement a topology. In 3 dimensions, there are many possibilities like that, where space connects to itself in repeating patterns. If our universe had such a layout, distant light might wrap around and show us repeats of the same galaxy in different directions, separated by huge times. Astronomers have looked for those echoes. They have searched for repeated circles in that old afterglow, as if the sky were a hall of mirrors. So far, no repeating pattern has been found on the scales we can observe. That suggests that if space loops at all, it loops on scales even larger than our horizon. Again, no rim, no immediate wall, just more. It is comforting, in a quiet way, to notice that the notion of a cosmic edge is not part of our best simple models. The equations that describe gravity and the expansion of the universe treat space as a smooth, continuous thing without a literal boundary where the math breaks. When you hear someone say that the universe is expanding, it is easy to imagine space growing into something else, into a surrounding emptiness. But the picture is calmer and more self-contained. Space does not grow into a container. It simply stretches. Distances between far-flung galaxies increase. New room appears between things as the fabric relaxes. The often used balloon illustration helps. You can draw little dots on a balloon and gently blow air into it. Every dot moves away from every other dot as the surface grows. There is no special center among the dots on the surface. If there were tiny beings living only on that surface, they would see everything recede from everything else. The inside and outside of the balloon are not part of the two-dimensional surface world of those beings. Likewise, in our three-dimensional universe, the expansion does not demand an external space to expand into. Space grows in itself. Back to the question of an ending. If you travel in one direction forever, do you reach a place where space stops? In the standard picture, the answer is no. You either continue without border, or, after an immense journey, you return to familiar territory because the universe closes in on itself. Neither choice gives you a cliff. There is, however, a subtle and gentle limit of a different kind. Even if space has no edge, you cannot see or reach everything. That is because of both time and expansion. Remember the fog analogy. There is also another horizon that cares about the future, not the past. Because the expansion of the universe is speeding up, driven by something we call dark energy, there are galaxies so far away that light we send now will never quite catch up to them. They will remain out of contact forever. This creates an event horizon, not a barrier in space, but a limit on who can exchange signals with whom. In the long, long future, the most distant things will fade from view as their light stretches away and thins below any possible detection. The local group of galaxies will remain. Beyond that, the universe will still be there, calm and wide, but much of it will be beyond our reach. This again is not an edge. It is a limit of communication. To get a better feel for all of this, it can help to take a slow walk through how we know what we know. When the universe was very young, it was hot and filled with a smooth, glowing soup of particles and light. Tiny ripples, seeded by quantum fluctuations and served by a rapid early expansion, played like gentle sound waves through this soup. As the cosmos cooled, atoms formed, and light could travel freely for the first time. The sound waves froze in place, leaving a faint fingerprint. We observe that fingerprint today in the afterglow. Its pattern is not random snow. It has a particular size and spacing of hot and cool spots, a balance between big and small that encodes the geometry and content of the universe. By carefully mapping this pattern across the entire sky, missions like WMAP and Planck have measured the overall curvature. The result whispers the same message each time. Space is very close to flat across the scales we can access. That does not prove infinity, but it does remove the need for a boundary. It nudges us toward a universe that is either infinite or so large and gently bent that any loop is beyond our horizon. Another strand of evidence comes from the way galaxies are arranged. On small scales, gravity pulls matter into clusters and filaments like a frothy web. On huge scales, the web smooths out. The average looks even. This evenness, along with the specific bumps in the distribution of galaxies, lines up with the story told by the afterglow. Small differences in the early universe grew over billions of years into the vast structure we see today. And again, when we look at that structure at the largest scales we can probe, we do not see a direction that behaves strangely, or a place where things thin out in a way that would hint at a nearby edge. There is a quiet elegance in how the simplest model of the universe handles all this. It assumes that on the largest scales, space is the same everywhere and in every direction. This is called homogeneity and isotropy, words that just mean no special places and no special directions when you average over big volumes. If that symmetry holds, and if the content of the universe is evenly mixed on average, then the equations of general relativity, our best theory of gravity, offer a family of solutions. Some of those solutions describe expanding space. Within that family, the existence of a boundary would be an extra, awkward feature. The simplest versions need none. In this sense, an edge is not just unnecessary, it clashes with the smoothness we actually observe. It is natural to wonder whether the universe has a center. In pictures, we often place our Milky Way somewhere on a paper, and circles around it look like a center is obvious. But the center we draw is only the center of our diagram. In the actual universe, if homogeneity holds, every observer anywhere would see galaxies receding in the same balanced way, with no privileged point. Imagine you are on a boat in the middle of a calm sea that goes on, at least as far as you can tell. The horizon is a circle around you. You might feel like the center because the horizon looks symmetric. But another person on another boat far away sees the same scene with themselves at the center of their circle. Each viewpoint is valid. Neither needs a true center on the sea itself. This is how the universe appears to behave on large scales. There is no special middle from which everything expands. Space simply stretches everywhere at once. The thought of infinity can be heavy if held too tightly, but it can be light if you let it be. Infinite space, in a practical sense, does not change the cozy details of your room tonight. It does not flood your senses or overwhelm your life. It remains a soft mathematical property of the backdrop. If space is infinite, there are infinitely many regions, most of them beyond any possible contact. They do not press on you. They do not demand attention. They just are. If space is finite, yet unbounded, the comfort is similar. The lack of edges means no cliff for the mind to worry about. The universe is self-contained. It curves back into itself in a way that is difficult to draw, but easy to live with, because it spares us from needing an outside and prevents the story from stopping. Sometimes people ask whether there is an outside to the universe. The word outside suggests a place you could stand and look at the whole. It is a natural image because we are used to smaller things with surroundings. But when we talk about the entire space that contains everything, the concept of outside loses meaning. It is not that there is a wall and beyond it a blank. It is that outside is not a direction you can name. In the balloon picture, the surface dwellers have no up or down off the surface. The world they inhabit is complete in its dimensions. In our case, with 3 dimensions of space, the notion of outside the entire space is similar. The map stops being a map to anywhere you can go. This does not close off imagination. It simply clarifies the language in a gentle, respectful way. It can help to connect these big ideas to the quiet details of measurement. When astronomers gauge distances, they do not roll out a tape measure. They use light itself. Light has a rhythm. Atoms dance and emit light with specific colors. As that light travels, the expansion of space stretches it. The stretch shows up as a shift toward the red end of the spectrum. By measuring that shift, astronomers infer how much the universe has expanded while the light was on its way. By comparing many objects at many distances, they weave a map of cosmic history. That history tells us how quickly space is stretching now, how it changed over time, and what that says about the content of the universe. The current picture points to a cosmos with ordinary matter, and dark energy, a smooth pressure that accelerates the expansion. These ingredients influence the large-scale geometry. With the observed amounts, the flat or very nearly flat case emerges. Inflation, a theory about the very first moments, also plays a calm role here. It suggests that right after the universe began its known history, space expanded extremely fast for a very brief time, ironing out curves and smoothing out wrinkles. You can think of it as pulling a crumpled cloth taut. If inflation happened, it would explain why space looks so uniform across great distances and why its curvature is so small. Although we do not see inflation directly, it gives a simple way to understand the evenness of the afterglow and the near-flat geometry. It also suggests that if space is not truly infinite, it is at least much larger than the part we can see. Again, no edge is needed. Even in a calm setting like this, it is okay to wonder what the words mean at the edges of our knowledge. When we speak of the beginning of the universe, we are careful. The beginning is not a place in space. It is a condition of the whole, a moment in time when the density was high and the temperature was hot. When we speak of the size of the observable universe, we remember that the number describes how far light has traveled, taking into account the growth of space along the way. There is a pleasant subtlety in these definitions. They invite patience, not urgency. They reward the steady breath. The question of whether space ends has another layer that people sometimes bring up. What about the idea of multiple universes? In that idea, different regions might have different properties. Some might be infinite, some finite. Some might be small bubbles in a larger froth. This is a speculative thought, not settled and not necessary to answer our gentle question. Even if there are many regions, each would have its own geometry and its own horizons. The immediate truth remains that in our region, the best evidence points to no edge within reach. Whether there are other regions with different physics is a separate puzzle, a quiet meadow we will walk through on another night. You can also turn the idea inside out by thinking about time instead of space. Does time end? The honest answer is that in our best simple models, time stretches forward, always adding more moments. There can be special places, such as inside black holes, where the equations predict a breakdown, but those are regions isolated by horizons, not walls in space you could bump into by drifting in an ordinary direction. In everyday cosmic life, for stars and galaxies, time just goes on, while structures evolve and cool. Over immense spans, stars age, light thins, and the universe grows even more spacious. That long view is not something to fear. It is a background story that asks nothing of you besides a moment of quiet acknowledgement. Now, gently return to our big question and soften it. Instead of asking whether space ends with a wall, we can ask whether the universe is complete without one. The evidence says yes. The models say yes. The experience of looking up on a clear night and feeling no boundary in your heart also says yes. When you step outside and breathe under the sky, the ceiling you feel is not the universe. It is a cloud layer, or the limit of your vision, or the simple fact that your body is small in a very large place. The universe does not fault you for that. It holds you in a small human scale and carries on at its own pace. Pause for a moment with the imagery that helps. The ocean is a favorite because a horizon at sea resembles the cosmic horizon in spirit. Standing on a quiet shore, the water curves away, and the line where sea meets sky is an illusion of distance, not a border. Ships vanish not because they hit a wall, but because Earth is round and your view is limited. In the universe, the horizon is not created by curvature alone, but by the combination of space and time. It is a boundary of what can be known today, not a frontier that must be crossed to find new kinds of space. If you climbed higher on the beach, you could see farther over the ocean. In cosmology, the way to see farther is to wait, to let light travel longer. As the years pass, new light arrives from more distant places. Yet because the expansion is accelerating, there is a limit to how much waiting can reveal. The sea remains vast. The sky remains wider. Still awake? Comment the secret word, nebula. Take a slow breath and let your attention soften. You might notice the way your shoulders feel against your pillow, or the way the air in your room moves. The universe does not rush. You do not need to rush either. While you rest, it expands. While you rest, ancient light from distant galaxies trickles in, a handful of photons at a time, arriving like tiny footsteps on a wide, soft path. They bring a story that is simple and gentle enough to be learned even half asleep. Another theme in this story is the idea of scale. On human scales, we are used to objects we can walk around. A house is solid. A park has a fence. A city ends and a countryside begins. It is natural to carry those expectations into the sky. But cosmic scales are so large that our daily sense of edge and border lifts away. Think of drawing a small map on a balloon. In the tiniest patch, it looks flat. You could add a tiny fence. The fence makes sense on that small piece. But if you keep drawing and step back, the fence is just a mark on a larger whole that curves into itself. In the same way, ideas about borders in space belong to small, local structures. There are edges to stars, the outer layers where gas thins into surrounding space. There are edges to galaxies, places where the brightness fades into the dark between. But the space between galaxies does not end in the same way. It continues, smooth and quiet. The way gravity works also leaves room for a universe without edges. Gravity does not need a container. It is the bending of space and time by mass and energy. Given enough mass in one place, space can curve strongly. In a galaxy cluster, the bending is large enough to deflect light. We call that lensing. Even so, the global picture remains smooth. The bending is local ripples on an otherwise broad surface. The gravitational field of the whole universe is not like a rope held at two ends. It is like a fabric without seams, its details changing from place to place, but its overall thread continuous. Consider what it would mean to have a literal edge. There would need to be a special place where the laws of physics changed abruptly, or where space simply stopped and another kind of nothing began. This would break the uniformity we observe. It would create signatures we could potentially detect, like sudden imbalances or sharp features in large-scale patterns. No such signatures have appeared. Instead, every test we apply yields smoothness. The faint ripples in the afterglow match a world evolving gently under the same rules everywhere we look. That is reassuring in a sleepy way. It means the universe is content to be simple in its overall shape. Edges would be loud. The universe, at least to the limit of our hearing, is quiet. If you enjoy visual images, you might try a thought journey. Imagine you are a traveler in a roomy spaceship, unhurried, with a window the size of your wall. You decide you will point the ship in one direction and drift for as long as you like. The view changes slowly. A star passes, then a dark stretch, then a galaxy from far away, like a soft smear growing and shrinking in your window as the ship glides past. Nothing announces an approaching boundary. There is no glow ahead, no thin line. Space is like a deep lake at night, unknowable in extent from any single vantage point, but smooth at each step. You could keep going this way forever in an infinite space, or eventually return to a neighborhood that looks familiar in a finite, unbounded space. In either case, there is no edge in the sense of a drop-off. The journey never reaches a rim. Now let yourself be curious about the words we use, because language can lead or confuse. When we say the universe is flat, we do not mean that it is a thin sheet. Flat here is a gentle technical term that means distances add up the way we expect in ordinary Euclidean space across large scales. When we say the universe is expanding, we do not mean things inside rooms are stretching. Local structures like atoms, planets, and galaxies are held together by forces stronger than the very slow expansion. The growth happens in the empty stretches between galaxy clusters, in the calm dark where gravity is weak. It is slow enough that galaxies can continue their complex dances for a very long time, while the overall fabric relaxes. You may also hear the phrase observable universe. The word observable does not trivialize the beyond, nor does it claim there is nothing else. It simply gives a name to the practical sphere of what can be seen from here, now. If there were astronomers far away in another galaxy, their observable universe would overlap with ours, but not be identical. They would have their own horizon, defined by their own place and time. No single observer can see everything, but the overlap is enough to tell a coherent story. The pieces fit together into a larger quilt. You might like the idea that the universe is not only big, but gently knowable. That is a gift of the last century of observation. We do not need an absolute view to learn. We only need to collect small, patient measurements of light and let the math work quietly. It is like listening to a soft piece of music played very slow. The melody reveals itself over minutes, not seconds. The universe played its early chords long ago. We sit here now on a small planet, and we can still hear them if we pause and listen to the sky. Topology, the subject of how spaces can be connected, adds a playful softness to the story. It tells us that space can be arranged in ways that do not match our household images. A three-dimensional space without edges is not a paradox. It is an allowed structure. Scientists have tried to spot signs of unusual topologies by searching for repeating patterns. Think of it like this. If the universe wrapped around in a relatively small way, the afterglow sky might show pairs of circles with matching patterns in different directions, like you are inside a mirrored room with a complex wallpaper. The absence of such matched circles, down to the sensitivity of our maps, tells us that if there is such a wrap, it is on a scale bigger than we see. That conclusion is not dramatic. It does not demand any specific model beyond the quiet statement that our patch is big and simple. As your breathing continues at its own pace, you can let these pieces stack like soft blankets. Space seems to be large. Space seems to be either infinite or finite without edges. Our view is limited in time, creating a horizon rather than a border. The patterns in ancient light tell us the geometry is flat on the largest scales we can test. Searches for loops and mirrors have not found any within our view. The expansion of space carries distant galaxies away faster than we can catch. But this is not a rim. It is a story about reach, not about ends. There are more gentle aspects to savor. The night sky once presented a puzzle known as a paradox about darkness. If space were infinite and unchanging and filled with stars, then every line of sight should eventually hit a star. The sky would be bright everywhere. Instead, the sky at night is dark. The resolution is calm and elegant. The universe is not unchanging. It has a finite age. There has not been time for light to arrive from every direction, and the distant light that does arrive is stretched into wavelengths that are not visible to our eyes. The darkness is not a failure. It is a clue to the nature of the whole. It is the quiet between the notes that lets the melody stand out. In the foreground of all this, life on Earth continues in a warm, familiar scale. You might be listening near a window with a curtain, or nestled deeper in a room with soft light. You might hear a distant car, or a heater, or nothing but your own breath. The universe holds those small sounds without strain. It holds mountains and rivers and cities, and it holds the space between galaxies, all in one fabric. There is something very gentle in that thought. The idea that everything occupies the same continuous field is calming. There is no outside to your experience tonight. No separate container that needs an edge. There is only space, and within space, your life. A common worry about infinity is the fear of being lost in something that has no end. It can help to flip that feeling around. You do not need to explore infinity to be at home. You do not need to travel far to belong. The fact that space probably does not end does not demand anything from you. It simply means that if one could travel forever, one could continue. It means the world is wider than any plan. That width can make your own plans feel lighter, less like obligations, and more like chosen paths. Gazing at something limitless teaches humility, but also kindness toward yourself. You are not in a race with the universe. You are part of it, moving with it, resting with it. Think again about the balloon, not as a toy, but as a symbol of growth. If the balloon has tiny specks on it, the distance between specks grows as the balloon inflates. None of the specks needs to be at the center. The surface itself is all there is for those specks. Translating that idea into 3 dimensions, the distances between clusters of galaxies increase. That does not make your room grow or your body stretch. Local forces keep local things held. The growth happens where gravity is weak and distances are large. It is a patient, spacious process, not a burst. It is so gentle that only over millions and billions of years do the changes add up to something you can describe with a calm sentence. When you step outside in daylight and look at the sky, you see blue scattered light from the atmosphere. At night, you see pinpoints of stars and the glow of your local galaxy. With a telescope, you see more. With a radio dish, you see the afterglow everywhere. Each of these views is like a lens that emphasizes one layer of the universe, like a painter adding transparent washes to a canvas. No layer shows a border. They show structure, waves of brightness and darkness, clusters and voids, but no rim, no corner of the map that says, "Here be nothing." The simple consistency of this observation, repeated across methods and wavelengths, is part of why the no-edge picture feels reliable. It is not based on one dramatic feature. It is based on 100 quiet agreements. We can also be humble. Our conclusions are the best we can do with the data we have. They might evolve as instruments improve. If a subtle curvature exists, we may measure it more precisely. If a repeating topology is present at some very large scale, evidence might appear in future maps. Science leaves space for updates. But those updates, if they come, are not likely to change the central comfort. The options on the table remain soft. No leading model inserts a sudden wall. No healthy geometry insists on a border. The adjustments are all about how big, how flat, how the whole knits together. Imagine again your drifting spaceship. Now imagine looking backward instead of forward. You see a trail of light, but it is not truly a trail. Space leaves no wake. The space behind you is the same as the space ahead. If you were to stop and hover near a friendly star, you could watch the universe unfurl in slow motion. Galaxies drifting farther apart over lifetimes, then over longer spans beyond any one life. You could collect the soft, thin rain of ancient photons, tiny carriers of information from the past, each one telling you that in its long journey, nothing like a wall ever showed itself. It left one galaxy, crossed a void, perhaps was nudged by gravity near another, and then arrived, unharmed by any border. The edge question sometimes slips into a question about meaning. If there is no end, does anything matter? If there is no outside, where does purpose live? These are tender thoughts, and they deserve a gentle touch. The cosmos does not give you a script, but it does offer a setting of astonishing calm. Within that setting, small kindnesses matter. A quiet night of rest matters. A deep breath matters. The absence of an edge does not reduce the value of a moment. It gives the moment a vast backdrop. It allows your life to be a bright, local warmth in a kind, cold expanse. It lets your choices be intentional against a peaceful, indifferent sky. Let the idea settle now. Space, as far as we can tell, does not end with a wall. The part we can see is wrapped by a horizon made of time, not of brick. Beyond that horizon, space likely continues. It may go on without limit, or it may close on itself so gently and so widely that we would never notice. Our instruments, reading the oldest light we can catch, suggest a flat geometry which fits cleanly with either an infinite space or a very large, unbounded one. The search for cosmic mirrors has found none within reach. The expansion we measure does not imply a rim. It implies a story of stretching distances and calm acceleration. If you are drifting towards sleep, you can let the rest of this wash over you like a soft tide. You can imagine the Milky Way, our home galaxy, drifting in a local group with a few neighbors, floating in a dark, smooth pool. Around that, a larger sea of galaxies spreads, each a small lighthouse in its own right. Between them, the dark is not empty of meaning. It is the stage that allows the lights to shine. It is the field that allows structures to form. It is the canvas for the universe's quiet painting. On this canvas, there is an absence of borders in the broadest sense. There are boundaries within science that are about what we can test and know. Those limits move as we build new tools and ask new, gentle questions. The question that brought us here tonight is not one that can be answered by traveling to the end. It is answered by listening to the available clues and seeing which stories fit them with the least fuss. The story that fits best is the one without a hard end. You can rest in that thought. There is no need to push further. The sky will still be there tomorrow, and the next night, and every night you care to look. Space does not close in if you stop thinking about it. It does not withdraw if you fall asleep. It is patient and vast, and in that patience you can find an echo for your own rest. Let your breath find a steady rhythm. Let your mind loosen its grip on daylight tasks. Let the idea of an unbounded universe be a large, soft pillow behind a smaller pillow, a cushion behind a cushion, supporting you without pressure. And as we ease toward the end of our time together, remember the simple answer carried by all this gentle detail. Space, in our best understanding, does not end with a wall. It either continues without limit or curves so subtly that it loops without an edge. What ends for us is visibility, at a horizon made by time and expansion. The night is not a barrier. It is an invitation to feel part of something quietly complete. Thank you for sharing this peaceful journey. If this helped you relax, a gentle tap on like and subscribe helps you find your way back to more calm science when you need it. Sleep well and let the universe be wide and kind around you.